Hello, this is Harald Meyer from Team NodeXL at the Social Media Research Foundation. I'm sure that many of you have heard of our tool or maybe have even used it, and all the insights that I will present in the following have been created with this tool. I started this research project on the German Bundestag more than a year ago when I was exploring Twitter user lists. Now, what is a Twitter user list? Any Twitter user can create such a list with his or her account, add users to it, and then access it via the Twitter search API to download these tweets. And the data contains only the tweets of the users on that list. In my opinion, these lists are very helpful and far underutilized. Now let's take a look at the current Twitter usage in the Bundestag. There are 709 members of the Bundestag. 77% of them have a Twitter account. So that means there are 547 users on my list. And my general research question is, what can we learn when applying social network and content analysis to tweets from politicians in a parliament? And here are the more focused research questions with regard to cluster analysis, overall party metrics, and vertex metrics. With regard to cluster analysis, the question is, how does party affiliation align with network clustering? Regarding the overall party metrics, which party is most central or peripheral, which party is most unified, fragmented? And with regard to the vertex metrics, the question is, who is important within and outside the Bundestag? On the right, you see the method that I've used. So it starts out with a Twitter user list, the collection of the tweets, and then the data is enriched with additional information, such as the party affiliation of the user and the party color. With that data set, I create several data subsets for further analysis and then apply social network and content analysis with NodeXL. I've created monthly updates for the past 12 months, and well, here are the results. Before looking at the network maps, I would like to point out the relationships that we have in our network data. So we have the relationship tweet, which is a self loop, which means there's no interaction at all. There are retweets, which are mainly used for amplifying messages. And then we have replies, which means you are talking to someone in a tweet. Or then we have mentions, which means you are talking about someone. And now when we summarize this part here, the interactions by replies and mentions, then we can say, well, which party is most interactive or least interactive. These are the bottom categories here. And we see that the FDP, the liberals, they have around 65% of replies and mentions, which I then define as most interactive. Opposing to that, we look at the AfD, and they have just 38% with this in this category, which means the AfD is the least interactive party. Here you see the full network map for the month of June 2020, which contains all tweets sent by members of the Bundestag within this time period. Every colored vertex is a member of the Bundestag, and all vertices that are colored in gray are Twitter accounts outside the Bundestag. At the top of each group, you see the top hashtags that were used in each cluster, which is very helpful to figure out which topics were discussed in these clusters. The cluster algorithm used throughout these analyses is Clausen-Newman-Moore. And on this map, we have 3 layout algorithms in place. The group in a box layout, and These boxes are laid out as a tree map, which means the largest cluster is laid out in the top left corner and the smallest cluster in the lower right corner. And within these boxes, the vertices are laid out with Harold Coren fast multi-scale layout. With regard to cluster party alignment, the question is, why do we observe these clustered coalitions where 2 or 3 parties are clustered into one group? The answer to this question is found in part in the cross-party interaction of the politicians, and on the other hand in the intermediary Twitter accounts outside the Bundestag that are in the center of these clusters. On this slide you see an overview of possible data subsets that can be derived from the full network map, with each of them providing a different perspective on the data. For example, we can filter the tweets by party to look at party networks. We can filter by topic to see discussions around coronavirus or climate change, for example. And we can also filter the data by network reach. So here we have the internal network, and this data set contains only tweets when members of the Bundestag talk to each other. And you see that we have a different coalition here than in the full network map. This internal network can be filtered down even more to a cross-party network to look at what the politicians are saying when they talk to another politician from another party. And from this cross-party network, we can derive the party interaction network to see on the party level how the politicians are talking to each other on the party level. Different look on the data are networks by relationship, so we can just only look at retweets, mentions or replies, and you see there are also different structures here. Especially the retweet network will show very distinct and dominant groups by each party. And when looking at these networks by edge weight, which means we raise the connection strength a little, and then this network also becomes very clear with dominant party clusters. In the following, I will focus just only on these maps here at the top. Here we can compare 3 monthly data sets with regard to the full network and the internal network. Full network maps are at the top, internal networks at the bottom. And we can observe changing clustered coalitions over time. It's interesting to see that the Green Party and the Left Party are clustered into one group here, here, and here. That can also be observed in the internal network here. But in the other internal networks, we see different coalitions. Here is the coalition of the governing parties, and here we have a coalition of the CDU-CSU with the Green Party. And it's this ambiguity between these network levels that I find most interesting when comparing these maps. I believe it's the ideological landscapes around the parties that are responsible for this green-left coalition. Now let's have a look at the interactions on the party level derived from the internal network data sets. The Left Party is at the bottom left. Here's the SPD, one of the governing parties, the Green Party up here, CDU-CSU is here, the Liberals, the FDP is here, and the AfD is down here. And we see a very clear pattern, not only in these monthly data sets, but throughout the past 12 months. And the first finding is obvious, which says that the governing parties, CDU-CSU and the SPD, are the most central parties in the Bundestag. At the same time, the Green Party and the FDP are interacting with these governing parties. And the third finding here is that the Left Party and the AfD are most peripheral. They are not integrated in the Twitter communication within the Bundestag. The AfD is even more peripheral, though there are just a handful of tweets directed at members of the AfD each month. Let's take a look now at the internal party network metrics to figure out internal network structures of the parties by considering graph density, reciprocated vertex pair ratio, and the average geodesic distance. Here we can also observe some recurring patterns. Graph density comparison may not be such a good indicator because of the different sizes of the governing and the opposition parties, but it's good enough to compare opposition parties because they're about the same size. We can see that the Green Party has the most dense network. At the same time, the reciprocated vertex pair ratio is highest, which points to the fact that the members of the Green Party are talking to each other more than the other parties within their party. And also the average geodesic distance is shortest than the Green Party. In my opinion, high graph density, high reciprocated vertex pair ratio, and short average geodesic distance are indicators for party unification. So that's why I would say that the Green Party is the most unified party in the Bundestag. Another interesting pattern can be observed when looking at the use of positive and negative words by each party, which are shown in the tables at the bottom. Here you see that the share of positive words is highest for the governing parties, while the AfD uses the least amount of positive words. Opposing to that, we see that the government parties have the lowest share of negative words, while the opposition parties use more negative words. And the reason for that is probably that the governing parties have to praise their own work in a positive way, while the opposition parties criticize this work in a negative way. Now let's move on to find out who are the top influencers within the Bundestag. This table here is ranked by between centrality, and I find that there are two categories of influencers. In bold, you see the highly connected users, which are high-ranking party and government officials. They have a high in degree and a low out degree. And the second category are the interactive users, who may not be that influential at all because they gain a high value in between a centrality with a low in degree and a high out degree. There's something to keep in mind when looking at between a centrality. I like to lay out this data in a scatter plot with between a centrality on the x-axis and eigenvector on the y-axis, and this way we see the really top influencers in the top right corner of this scatter plot. When looking at the external influencers, so those Twitter accounts outside the Bundestag that are mentioned by members of the Bundestag, you see three main categories. First category are party-related Twitter accounts, which serve as network hubs for each party. The second category are large media and news outlets, which means that sharing or commenting on the daily news is part of the overall networking strategies of the members of each party. And the third category shows regional or international politicians, which is also a reflection of current discussions in the political arena. Here's a short overview of the main findings, and I would now like to point out a few things for future research. We need more network maps. I think we can all agree on that. I would like to see this method applied to all parliaments in the world and be able to compare parliaments on the overall level, but also parties on the party level. And it would be also interesting to compare finding to the networks on other platforms like Facebook or Instagram, where it's nowadays incredibly hard to get any data at all. And another thing that I would like to point out is that the amount of time needed to create a set of network maps that I've just presented only takes a few hours for each month. So if you're interested in this approach for your own research, feel free to contact me. And that's all. Thank you for listening and watching. I'm now ready to answer your questions.